Good. Sorry. Hi everyone, my name is Chen. Today I'm going to talk about long distance biotic dispersal of trophical sequences by marine mega herbivores. And first, what is herbivores? The herbivore is a huge animal, and they eat vegetables. And they are vegetarians. And to this study's end, we know the terrestrial angiosperms, they have animals that eat their fruits or seeds to become, and they produce fecals, so-called animal turds. They contain the seed, and the plants can grow by their digestive systems. What about the marine angiosperms? We don't know. So our object is determine whether the seagrass seed pass through the digestive system after eaten by the herbivore, mega herbivores, and which can still remain viable. It can grow. And second, we determine the species, the numbers, and potential dispersal distance. And the species is the sequence species and sequence numbers. And the potential dispersal distance is that they can flow by animals' turds, how far they can of this sequence species consumed by mega herbivores. And material and method. The material and method, we collected dugongs and green sea turtle fecal samples every month, and from 2014 September to 2014 December. And during the period, it's right on the period of the sequence maximum sexual reproduction, and the three sides of the Great Barrier Reef is a Caroline Bay, Upstart Bay, and Pioneer Bay. And we collect the fecals on the water surface, just by on the figures which is by net. And first, we divided into three sides of the fractions. And before remove the seed coats, we identify the species and count the numbers. After remove the seed coats, for those non-germination seeds, we use the stem with a solution to determine viability. And if the tissue turns brown to red or pink colors, indicates that the seeds were still active and capable of germination. And I want to talk about the germination and viable. The germination, you can see the seed, you can see a little bit of green, like they already have some sticks or something like that, first sticks on the seeds. For us, not germination seeds, we just look at it, it's just like this. It's nothing changed, not seed coat split, they just remain as seeds. And the result, we cannot identify whose fecals is, so we combine into the sea turtle and dugong fecals into marine mega herbivore fecals. And the fecal sample, the mass is ranging from 0.02 dry weight. We dry the fecals into the ovens and test the dry weight. And to maximum 7.696 gram dry weight, with the average of 1.37 plus or minus 0.18 dry weight. The sequence is with the mean number in the vehicles are between 1 to 2 seats in vehicles meters. And this bar is talking of the y-axis is the number of vehicles and the x-axis is the month. And in November, we collect 4 vehicles, and 10 we collect 15. In November, we collect 19. In December, we collect 22. And we must sequence seeds in 56% of our marine mega hoverboard vehicle samples. And in these figures, this species, Rostera valeriura, and are the most. Why they are most? Because they are living strategy. They grow higher than others secrets. So it can easy to eaten by mega herbivores. And we got class 3 Halodura universe and Halophila species, and some of identified Halophila species. For easy to pronounce, so I call this one called this species, and call this one Halodura species, and this one called Halophila species, and this one cannot identify, we call other Halophila. And the seed, except for Halophila species, all species of sequences found in fecal samples, including at least one seed with a split coat. And the viability. So we know the germination of seed collect from mega hoverboard fecal occur prior to viability test for this species, Halophila species, and other species, but not for Halodura species, because here we can see all of the Halodura species all have the split coat, like this figure. There's some green we can see. And as a germination in the identification of viability, this seed will consider viable. And those who remain non-germination seeds, only this species seed test as viable. This means it turns pink or red. That means percentage of viable seed species collect 9.13%. And the seeds we collect in color bay density is 153. The fecal sample in here contains seeds are around 60%, and upstart base the density of seeds are 9, and fecal sample contains seed is 30, and pioneer bay density of seed is 72, and the fecal sample contains seed are 45%. And the seed, we look at the bar first. The y-axis is proportion of viable seeds, which means the seed and the percentage of this viable in different months. You can see the numbers. The means of it doesn't have any change. in different months. And the proportion of seed, this bar is y-axis is the proportion of street seed. The species, which I talk here is the seed code is already split out, and we can see time and size of collection have no significant effect on the proportion of seeds which had their seed code split. Yes. And to the discussion, viability of seed, we found 1 to 2 seeds in pure grain of dry weight in mega herbivore fecal matters. And over half of seed extract has a split seed coat. And these species with the seed coat still maintain viability after digest at 9.13%. And viability of seed, time and size has only a minor effect on the number of seeds found. And this most likely due to the different sequence location peak in reproduction in the flower season for this species. And animal count, there are around 4,000 to 6,000 dugongs and 855,000 sea turtles. There will be average up to 2,000 viable seeds for dugongs, and up to, you can see too many sea turtles, so we can collect 500,000.
Okay, to conclusion.
The conclusion, this study has a confirmed biotic dispersal of viable seagrass seeds by marine mega herbivores. And this dispersal mode has the ability to contribute the resilience of seagrass meadows and aid in recover after we lost.
Okay.